afternoon. I know just a session straight after lunch. This is a session which I read the most. Hopefully, you all had a quick nap. At least you had time to have a quick nap. And we'll begin up with the matinee show, a small video. So let's get started. My name is Govind. I manage the enterprise business for NVIDIA in the country. We just wanted to do a quick session, give you a quick overview of how generative AI is revolutionizing the space and how data engineering can actually play a role in better generative AI. So with that,
I am a translator, transforming text into creative discovery. Movement into animation, and direction into action. I am a healer, exploring the building blocks that make us unique, modeling new threats before they happen. Searching for the cures to keep them at bay. I am a visionary, generating new medical miracles. And giving us a new perspective on our sun to keep us safe here on Earth. I am a navigator, discovering a unique moment in a sea of content.
We're announcing the next generation.
And the perfect setting for any story. I am a creator, building 3D experiences from snapshots and adding new levels of reality to our virtual selves. I am a helper, bringing brainstorms to life. Sharing the wisdom of a million programmers and turning ideas into virtual worlds.
Build Northern Forest.
I even helped write the script. Breathe life into the words and compose the melody. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
guys, this decade is the decade of AI. Generative AI to be not going to be precise. This is a decade where AI will transform from being a tool to be a companion to mankind. That's where it comes from. We call it, with the release of ChatGPT, we call it the iPhone moment in AI. A lot of interest created across, a lot of people, even the common man who get what exactly this tool is all about. Just to put up things in perspective, any guesses on the adoption rate of WhatsApp, social media things which is revolutionized the world, WhatsApp, to get to 100 million subscribers or users, any guesses on how long it took? Any guesses? 8 years? Anybody else? 4 years? Almost right. It took 49 months for WhatsApp to get to 100 million subscribers. Same thing, Facebook, 42. TikTok, 13. ChatGPT, pardon? 2 months. 100 million subscribers. So this is a technology, this is a thing which is going to revolutionize the whole world. This is going to touch every enterprise. It's going to touch every humankind in the world this decade. That's it. And the adoption is so fast and furious. Now, if you look at the way it will actually move, it's really unlocking a lot of new opportunities for us. Forget opportunities. Opportunities will come to it based later. Now, this is a tool which will actually increase the productivity of people as a support mechanism. Now, if you look at it, once again, let's put things in perspective here. Electricity, between 1900 to 1940, it's supposed to have increased productivity by about 35%. Steam engine for large enterprises, it actually increased by about 25%. The internet, any guesses? Between 1995 and 2005, it supposedly increased productivity by around 15%. There is a recent study done by MIT which says generative AI can actually increase productivity by 50%. So this is going to be big. And it can touch anything. I've actually put up a lot of things. When you could see text generation, you could see video, you can support marketing, drug discovery. You take, most of the areas which you are actually familiar with, it can touch most of it. Actually, on the left side, what you see is a text generated by our own service, which is called NVIDIA Nemo service. We'll come to it with data. Now, if this is the way industry is going to change, this is the way AI is going to change, and generative AI is going to come into the picture. Now, how does this work? And what are the challenges which enterprise will actually face? Now, this is going to be adopted by every enterprise. So, take it from me, it's going to happen for sure. Now, how does it work? This works based on something called a foundation model, which is a large AI model, which is trained on a large data set. Basically, a self-supervisory kind of a training is what it does. And it can actually be provided downstream to cater to any workload. That's the way it works typically. Now, how do you put up a foundation model? Can every enterprise put up a foundation model? Certainly not. There is a recent submission or a discussion with Sam Altman, who is a CEO of OpenAI. GPT-2 was 1.5 billion parameters. GPT-3, 175. GPT-4, 170 trillion parameters. So he himself came out with a submission that this cannot scale the way it is. The way we are actually going, there is no way it can scale. So if you look at a foundation model which is put up in place in the back end, it is on a really, really large data set. Needs a lot of compute. It's a very, very complex algorithm which is actually driving the whole thing. Can anybody and everybody do it? Certainly not. So you have to take up the foundation model from somebody who is provided it. So that's the way it's going to work. Now, can an enterprise take up any foundation model and use it as it is? Certainly not. There are a lot of challenges which will come up there also. That's what you put on the right side. Now, when you take up a foundation model, it has to be fine-tuned. There are multiple things. They call it zero shot and P-tuning and a lot of algorithms there. In terms of fine-tuning a model, basically what you're taking is you're taking a model, which is a foundation model, and fine-tuning it to be specific to your domain. Fine-tuning it for your data set. That's the way it works. Like, let's take an example of a question which is posted to ChatGPT. What is a yolk in a egg? You can straight give you an answer, saying that yolk is the central part of the egg, it's yellow color. Answer is right. But now you bring in a context here, a domain here. Like if it's a nutritionist who's asking the question, it has to be relevant to the nutritionist as to what are the nutrition parameters. So the system is back-end model should understand who's asking, and that's the way the model has to be trained. The same thing changes for a culinary artist. So the system has to understand it. That's where the data and the fine-tuning which you have to do with the data becomes very, very critical. Otherwise, it doesn't make sense for an enterprise to adopt it. Now, these are the typical challenges, and that's where the next piece comes up. Now, in terms of taking a foundation model and adopting it for your use, you have to actually integrate it with your data set. that's where data engineering, aspect of it comes into the picture. So this is based on a large data set. It could go into gigabytes, terabytes and terabytes of data. It could be multiple different formats of data. It could be text, it could be, images, it could be videos, it could be PDF, it could be anything. So it's a diverse set of data which, has to be used which has to be taken out to fine-tune this whole model. It's a large data set. So you have to have a very sophisticated retrieval mechanism to pull out this data and fine-tune the model. That's the only way it's going to work. And that is the aspect where data engineering and data science will come into the picture. The data pipeline is very, very critical. Now, when you talk about data engineering, now what are the typical things which will come up as challenges? There are a lot of challenges in data engineering too. We talked about the data part of it, the humongous data which you need to use, the kind of diverse data, all that stuff we already talked about. The other aspect of it is the compute. Typically, this is a very parallelized kind of compute need. Now, you put a typical CPU and drive it, you will have people actually waiting for the results for so long. It's because it's sequential computing, it doesn't work out. So you have to change it from a sequential computing to a heavily parallelized kind of computing. That's only we can do it. And that's where the GPU comes into play. NVIDIA comes into play. Now, let's look at the last part. Most of you are actually working in this area, you might know it better. Most of you will be taking up this, the models from the open source. The libraries, the frameworks, most of you consider it the open source. Just let me take up one example here, one question here of, let's say, a version control. How do you manage it? Now, which version works with what, and what is the kind of seamless management you can do with versions? That itself is a clear indication that you need to have a repository which gives you data, which gives you the models, which are fine-tuned for the compute which you actually put out. That's the only way it's going to work. So these are typical challenges which you face here. Now, with these, if these are the parameters, these are the challenges, these are the considerations which you have, what is NVIDIA, and what can NVIDIA do to help, or what are we doing to support this area and the development? Now, we today are a full stack company. Full stack, I would say a full stack AI company. Now, what I mean by that is what you can actually see in the picture here. On the top, what you see are the frameworks, the application frameworks which you have. These are all open source. Most of them are freely downloadable. I would say nearly all of them are freely downloadable for you. These are specific domains, like let's say Riva. Riva is the application framework for ASI, speech recognition. Nemo for LLM, large language models. Same way for Merlin, recommendation systems. So you look at specific use cases, you've got a framework for that across. So it's a huge list of frameworks you already have, which will support the models, which is water models, and even pre-trained models are available based on these frameworks available from NVIDIA today. But these are frameworks which you can take up to develop your application, your solution. That's the way it works. Now, all of this are based on NVIDIA's libraries called CUDA, which is the acceleration library. When I say acceleration, it's typically a library set which accelerates these application frameworks on the GPU. So these are all based on this. So you get the application frameworks, these are all accelerated to get you optimal performance on the GPU, and at the bottom comes the infrastructure which you need to put together to drive this whole solution. Now, when you put up the infrastructure, it can be done on the cloud. A lot of you might be using infrastructure on the cloud, quite possible. You got the complete GPUs and accelerated compute available on the cloud. You can actually do it on-prem. So that decision is up to you. Now, irrespective of whether you consume it on the cloud or on-prem, there is a solution available from NVIDIA which you can consider. Like, you want to consume accelerated computing, it's basically GPU computing on the cloud. You want GPUs available for everybody, like take Amazon to Microsoft Azure to GCP, all of them. You want to consume it on-prem, you are standing up an infrastructure to do it in-house, you've got a complete infrastructure which can be put up together with any of your providers today, like it could be Dell, HP, you name it, Gigabyte, anybody. On addition to all of this, there are certain appliances which are available from NVIDIA, which is basically what we call as DGX systems and so on, which is sort of like a server appliance for specific workloads, like let's say training, it's a very, very specific workload. You can actually get a system from NVIDIA itself and actually use it. So the infrastructure can be based on any of this. It can be cloud, it can be on-prem, and you've got the complete flexibility to choose what you want to based on the way you're working. Now, all of these systems are based on NVIDIA's reference architecture and certified by NVIDIA. That's the way it works. So these application frameworks which we're talking about are certified to work or give you the optimal performance on these systems which are already certified. Now, underneath all of this comes the compute element and the network element. Both of these are two critical things. Now, when it comes to compute, we talked about a CPU, which is sequential computing, you need a heavy parallelized computing, and that's what accelerates a complete workload for you, where the GPU comes into the picture. Now, the third element, which is, now you've got a CPU, you've got a GPU, and there is a third element, which is the I/O part of it. That's where the DPU comes into the picture. Now, if you look at any typical workload which you put up, let's say a training workload. Once you go to a multi, you can start with single GPU, you can go to a multi GPU kind of a system. So let's say 1, 2, 4, 8 GPU sort of systems. But if you go beyond it, you have to go to a multi-node kind of a system. That's where the network also plays a role. So we have a complete stack at the bottom layer where you get accelerated compute with any of this, as well as the network which is also accelerated, the lowest latency network. Latency is a big deal in this one. Like 1/3 or 1/4 of the latency of anybody else in the market can be available with NVIDIA. So if you look at it, this is a complete stack which is available from our end. You go from the bottom, it starts with the infrastructure layer, application and acceleration libraries, and the application frameworks. This is not a solution. We are expecting partners to take up this and do solutions based on what they actually have to deliver. That's where we go. We're not a solutions company, but a full stack company. Now, you might all be used to, a lot of you should be familiar with the left side, which is basically data science engineering is quite an old thing. Most of you should be working in Python. A lot of these are APS libraries which are available in Python. There's an exact, one-to-one correlation with what is available on the GPU also, which is heavily accelerated. Now, you take it from pandas to PDF to the bottommost on the visualization, you get it across. And these are very, very seamless. We're actually doing a Python code, a call to a pandas API. Will change to a PDF API. It's very, very simple and seamless migration from CPU to GPU. And I'm talking about CPU to GPU. I'll just come to it as to what we actually can deliver here. So this is in terms of the libraries across. Now, when it comes to data sciences specifically, you look at a typical ML pipeline. Data processing is very, very critical. Now, that's where we come out with a stack called Rapids, which is basically a library and an API solution, heavily parallelized, optimized to work on the GPU. Now, if it's a single node, it could be just Rapids. If it's a multi-node kind of an option, it could work with Dask, it could work with Spark, you choose it. Whichever way you want to deploy it, we actually want the flexibility to do that. Scalable solution. Now, you develop or deploy your Rapids. Now, what do you get? Let's look at a simple comparison. Just a very simple comparison. This is actually a mortgage workload, which is used for the benchmark. Family, the US company, is actually what did this whole thing. Top to bottom, it's all, I think, done in the cloud. You've got a CPUs doing the same workload, and at the bottom, the lowest one, you've got the GPU portion here. It's 16A100 from NVIDIA, which is used for this one. And on the CPU side, there are multiple configurations which have been done with this. On the data preparation side, it took us around 22 seconds to do the data preparation. Now, from there to the entire workflow, it is done in almost around 123 seconds. That's the comparison. 123 seconds for the entire workflow. You compare it to the CPU, even the data loading did not happen in 123 seconds. Entire workflow took around 53 minutes. That's a typical comparison. This is a comparison of CPU pandas versus GPU rapids. This is what you get. This is relevant. This is relevant and very, very critical for any data science and engineering lab. Now, there are multiple ways to look at it. They have faced even customer discussions where they say that, look, Open, I don't need more performance, I have good performance. Fine, that's one way to look at it. But if you look at the kind of workloads which are there today, generative AI and so on, performance is really, really key. You need multitude of what you actually have today in terms of performance. You've seen the performance comparisons here, 70x, 16x, whatever. Like the numbers are like magnitude, not just an incremental one. Now, let's go to a situation where the customer says, you're good with the performance right now, you don't need a performance improvement. But that's where you look at the other aspect of it. You can actually save significant as far as TCO is concerned. Now, I make this point because of one reason. Because typically, when we actually go back and talk to a lot of customers, they typically say that, GPUs are so expensive. Yes, GPUs are expensive versus the CPU. Absolutely right. I'm not denying that at all. But now you look at the cost per transaction, the kind of savings which you get in terms of number of nodes, in terms of power, in terms of whatever it is, and the TCO overall, that's where you get a saving. So it's not just a corporate capex additional which you pay for the CPU versus another compute device, the GPU versus another compute device. It's a kind of saving which you get, which is significant. And all these numbers are factual, and you'll see it because when I joined NVIDIA, is when I could make out that whatever the comparisons we're talking about is not in 10%, 15%, 20%. We're talking about, let's say, 10x, 20x, 100x, 150x. That's where comparisons go as far as performance is concerned. So you do rapids, this is what you get in the day. Now, this, you've got an extensive ecosystem which is already available because you all are may not consume it directly from us. We got startups to enterprises to OEMs to across the cloud providers, everybody. It's completely covered. We work with all of them. So consumption of a lot of these can actually happen through any of these. It could be an ISV, open source community which we actually work very closely with and optimize tools based on our libraries and acceleration platforms. You can consume it from anywhere. Now, we started with generative AI. So this is actually the way generative AI is linked to data sciences and how we can accelerate data sciences, data pipelines. Let's go back to generative AI and how that works out. Now, we said you cannot consume a foundation model as it is. I'm talking about enterprises here. You cannot consume it as it is today. So how do you change it? You definitely need to have a domain-specific knowledge infused into the model for sure, which needs fine-tuning. Whatever then, it could be prompt-based, it could be zero-shot, and it could be real fine-tuning. Whatever you want to do, you have to do it. And the second thing is you have to actually exclude a lot of data which is outside your domain, because it confuses the system once again. And is this a one-shot process? No. Let's take an example of they say the data is frozen in time. Once the foundation model is done, if you're actually using it, data is frozen in time. You go to a system like that, a foundation system, post a question, like let's say a oil and gas company. You're actually putting it up for some chatbot internally for internal consumers, and you're actually posing a question as to what is the pressure in this particular refinery, in this particular gas cylinder. What is the pressure? You get typically an answer that I have been trained 2 months back. I don't have the latest information. That's what you get. So this has to be, the data which is put up here, the proprietary data sources have to be kept current and has to be connected to the system for sure. Then it's a continuously improved model. What they call as reinforcement training is what has to be done to do this process, iterative process over and over again. That's what you get in enterprise grade generative AI system. What we are doing here is we are actually coming out with this as a service from NVIDIA. We've got it for 3 areas. The first one is NEMO is a large language model, which is basically for text. We've got BioNEMO service, which is basically for drug discovery and life sciences and the pharma industry. And the third one is Picasso. I'm sure a lot of you would have actually seen stable diffusion and sorts, text to video kind of a service, which is called Picasso. All of this works on what we call as a DTX cloud, NVIDIA supercomputing cloud. That's what it works on. And this you can actually consume it as a service. Finally, the last one, if you are clear that you want to do put up a complete system on-prem, we've got a framework which can be consumed under what we call as the NVIDIA AI enterprise, and you can develop your foundation model system. You can develop your generative AI system based on that on-prem. The other three are services. Now, when you come to the features of it, you look at it. Basically, there are tools available from our end which can make it very, very personalized. Most of what we talked about as challenges here, we've addressed it here in this one. It can be the best performance, the most easiest of use. The first, the curation of the personalization, a few code changes can actually get personalized for you on your data set. It's clearly a system which is designed for enterprise adoption. There is a recent case where I don't know if you read it, and this is even covered by most of the papers in India. One of the Korean companies, there are a lot of engineers, the software developers, actually went to ChatGPT and put their code, their in-house code, and asked it for opinion. Like, can you actually optimize the code? It became a major issue within the company. It actually got leaked and it was public, available in the public domain. The issue with such a thing is on a system which is available, the foundation model which is available today, most of them consume it. This data, what you're actually putting in there, is not protected for you. What we are saying is we actually will not share the data. If you are training the system, that system is specifically for you. That model is specifically trained for you. We are not going to take that data, train our basic foundation model, and then we will make it available to others. So this is proprietary, this is specific to you, this is your IP, you keep it. That's one of the biggest differences. A lot of things which we talked about are already covered here. I don't want to go through all of them. Most of it is available today. Some of it is work in progress as we speak. Yeah, one more minute. Oh yeah. Because they said they'll drink one well, then the second well, the third well they'll do me out is what they said. No. So on this one, I just wanted to touch on the Nemo service, the text to. This is the one which is most stable and available today. I just wanted to just have a look at what we can offer.
Sentences and trillions of words. As the model converges, it begins to understand the relationships between words and their underlying concepts captured in the weights in the embedded space of the model. Transformer models use a technique called self-attention, a mechanism designed to learn dependencies and relationships within a sequence of words. The result is a model that provides the foundation for a ChatGPT-like experience. These generative models require expansive amounts of data, deep AI expertise with data processing and distributed training, and large-scale compute to train, deploy, and maintain at the pace of innovation. Enterprises can fast-track their generative AI adoption with NVIDIA Nemo service running on NVIDIA DGX Cloud. The quickest path is starting with one of NVIDIA's state-of-the-art pre-trained foundation models. With the Nemo service, organizations can easily customize a model with P-tuning to teach it specialized skills, like summarizing financial documents, creating brand-specific content, and composing emails with personalized writing styles. Connecting the model to a proprietary knowledge base ensures that responses are accurate, current, and cited for their business. Next, they can provide guardrails by adding logic and monitoring inputs, outputs, toxicity, and bias thresholds so it operates within a specified domain and prevents undesired responses. After putting the model to work, it can continuously improve with reinforcement learning based on user interactions. And Nemo's Playground is available for rapid prototyping before moving to the Cloud API for larger scale evaluation and application integration. Sign up for the NVIDIA NeMo service today to codify your enterprise's knowledge into a personalized AI model that you control.
That's basically what I wanted to leave you with. We've got a service which is already available, and there is early access program which is available for you. Freely available today. You can just Google it, just go online, have a look at it, apply for the early access program. You can actually play around with the NVIDIA NeMo service. The other parts of it, anything to do with tablets, we can actually help you. If there is a specific need, you can reach out to NVIDIA, we can help you out. I'd say just let it go back. Anything to do with AI, we are actually there to support you and his job. So the time is up. But here now, I don't know whether there is time for Q&A. If not, I actually have a couple of my colleagues here. We've got Hasan, Aijaz, Vijay, Simran, and Avinash. They are the smarter people. So if you've got technical questions and deep dive discussions, we can have a conversation with any of us. We'll be around for some time. Thank you very much.